एवरीवन रेडी है? कैसी चल रही पढ़ाई? गुड. Have you gone through this sheet? Most of the topics we have covered already, so it will be a kind of revision for you, and few topics are there which are new, so we will discuss those topics. Ready? Hello everyone, good evening. We will be discussing about science and technology, current affairs, and it is an update. That means most of the current affairs we have discussed already, but few more topics have been added in last few months. Those added topics we are going to discuss in today's class, right? So shall we start? First few slides are about the topics that we are going to cover. So firstly, we'll be starting with ICT, that is information and communication technology, and under ICT topics are like, first is submarine cable system. So due to some unknown reason in Red Sea, submarine cables have been damaged, and that's why this topic is in use, submarine cable systems. And those submarine cables are used for what? For what purpose? Submarine cables are there. Submarine means underwater. Under the water we have some cables, and they are used for data transmission. Right? I think we have referred to this kind of thing. So it is used for data transmission. So that topic we'll discuss. Then there is a topic called as free space optical communication. Can you name this project? If there is a term, free space optical communication is carried out under which of the following project? Can you answer that question? Free space optical communication. Optical means we will be using laser light, right? Free space means cables are not there. We are using space, or let's say the surrounding. It's not exactly surrounding, but there will be no cables, right? So free space would be used for transmission of these optical communication radiations to allow communication, and that is being done under project Loon. Project Loon's successor. Project Loon was there. It was in news in 2016, but in 2024, Project Tara is in news, and this is carried out under a project called as Project Tara, right? Have we discussed this? Right? Can you please tell me, Project Tara is a project of which organization? It is a project of which organization? Its parent, means the parent organization is Google, right? It is Google's project, right? So initially they wanted to come up with Project Loon, wherein they were supposed to come up with balloons. Through those balloons they wanted to provide data transmission services. That means they were supposed to provide internet services through those balloons, but that could not materialize, and that's why they have moved further, and this is the project that they are targeting, wherein without any cables they will be using laser radiations for establishing communication. Light radiations will be used for establishing communication, right? So that is what is free space optical communication. Now similar thing has been demonstrated by NASA, right? See, this is for communication, this is for internet purpose, but similar thing has been demonstrated by NASA as well for making sure that deep space data that is being collected by different telescope, different satellites, is transmitted on Earth's surface. That project also we have discussed, and that project is called as DSOC, Deep Space Optical Communication. TSOC project of NASA. Right? Right now, what we use for deep space communication? Right now, what do we use for deep space communication? Which radiations do we use? Which waves do we use? Sorry? Radioactive? Radio waves. Radio waves we use. Right? So, radio waves we use for data communication right now. But in order to transmit more data, in order to pass on more data from those satellites to ground stations, they are demonstrating use of light radiation, visible light radiation, right? And that visible light is nothing but optical radiations. Right? So that is what is the topic, free space optical communication. Then next topic is near field communication, that is NFC technology. NFC technology, near field communication technology. So NFC is a long range technology or a short range technology? Short range technology. And can you please tell me the application of NFC that you are aware of? Right. Not in FASTag. Not in FASTag, but in this tap to pay features. Right? Tap to pay, credit cards, debit cards are there, and even tap to pay features have been introduced in Google Pay as well. Right? So that is what is the technology used in those tap to pay features. So that is what we will be discussing. Can you please tell me through which technology do they establish communication under NFC? What NFC uses in order to establish communication? Not infrared. Infrared itself is a separate technology that we use in remote controls. Sorry? Radio signals. Radio signals are used, but that is not the only answer that you should give. It is electromagnetic radio signals. Radio signals are used, and that leads to production of electric current, and that electric current leads to production of magnetic field, and that magnetic field allows two devices to communicate with each other. And that's why we have to take devices very close to each other, and that distance is around 4 to 5 centimeters. That closeness is necessary for NFC communication. Right? On the other hand, for RFID, there is certain distance is possible. Means from a certain distance we can establish communication. Fine. So that is what is NFC technology. Then supercomputers are also in news. We have already discussed. Can you please tell me a keyword for supercomputers? What exactly are supercomputers? Fine. As name suggests, supercomputers are those computers that can process huge volume of data in a very short span of time. Fine. What kind of principle do they use to carry out this data processing? They use a principle called as parallel computing. They use a principle called as parallel computing. Fine. So that we will be discussing. There is one supercomputer that has entered into top 100 supercomputers of the world from India, and that is Ahlawat. That we will discuss. Fine. Then 3D printing. 3D printing, again a keyword or a key technology that is used in 3D printing. The way supercomputers are based on a principle of parallel computing, 3D printing is based on, or a keyword is there, it is called as additive manufacturing. It is additive manufacturing. Additive manufacturing means what? Right, and it is different from subtractive manufacturing. Right, the traditional manufacturing that we use is subtractive manufacturing. Additive manufacturing, on the other hand, it does not eliminate, it does not remove any raw material. it add layers of raw material in order to produce the object. Fine. So that is what is 3D printing. Then India AI mission is also there that we will be discussing. It is little theoretical topic. Can you please tell me what exactly do we mean by artificial intelligence? What is AI?
Neural networks to mimic performance of human-like solutions.
So there are subsets of AI. The definition that you are giving is related to deep learning, right? AI has a subset called as machine learning, and machine learning also has a subset called as deep learning. Neural networks are more related to deep learning. AI, on the other hand, is a simulation of human intelligence by machines, right? When machines try to behave intelligent, then that is what is called as artificial intelligence, right? And today it is there in every field, means in most of the fields we have already started use of AI. Day before yesterday there was one article in the Hindu about use of AI for drug manufacturing. Have you read that article? A very important article was there. It is related to use of AI for drug manufacturing. Okay? So go through that article day before yesterday, the Hindu. Fine. So these are the topics that we will be discussing from ICT. Right? Next. Next technology is space technology. Next technology is space technology. So first topic from space is Pushpak reusable landing. It should be launch vehicle. Reusable launch vehicle. It should not be landing, it should be launch vehicle, right? So it is named as Pushpak. So what is RLV, reusable launch vehicle? Right, right. So whenever we discuss static part of launch vehicles, we discuss that the launch vehicles that we have right now, for example, PSLV, GSLV, and even SSLV, all those launch vehicles are expendable launch vehicles. What do we mean by expendable launch vehicles? They are single-use launch vehicles, right? You must be aware, launch vehicles work on the basis of stages, and as launch vehicles moves upward, all those stages fall off one by one, right? And that's why we are not able to reuse those launch vehicles. We have to come up with a new launch vehicle for a new mission, right? But this reusable launch vehicle technology, which right now we don't have, we do not have reusable launch vehicles, right? Right now reusable launch vehicles are there only with SpaceX, right? But whenever we have this RLV kind of technology, we will be able to reuse those launch vehicles, and that's why cost of launching would significantly reduce, right? So that is what we will be discussing. Then X-ray polarimeter satellite, X-ray polarimeter satellite, which is also called as XPOSat, right? What exactly it is, XPOSat? Fine, right? So it will be coming up with data related to angle and related to degree of deviation of X-rays coming from various sources that we have in the universe, right? So that information would help us get more information about the sources themselves. Fine. So that is what is XPOSat, and who has launched this XPOSat? XPOSat satellite is launched by which space agency? NASA or ISRO? Why you are underestimating ISRO? Right, it is by ISRO. NASA also has this kind of mission. It is called as IXPE mission. This is of NASA. NASA, you can say, was the first agency to launch such kind of mission, but this XPOSat mission is of ISRO. Okay? So IXP is imaging X-ray polarimetry experiment. Imaging X-ray polarimetry experiment with similar purpose. Next is Uncover program. Uncover program is a program related to JWST. What is JWST? James Webb Space Telescope. In one line, can you describe JWST? Yes. Fine. Not replacement. Hubble is still there. Right. You can call it right. You can call it scientific success. It is a scientific successor of Hubble. Right. Any other? A keyword is there. It is an infrared observatory. It is an infrared observatory. Hubble, on the other hand, is optical, UV, and near infrared observatory. Optical, UV, and near infrared observatory. But JWST is completely infrared observatory, and that's why it will be able to uncover. And that's why it will be able to uncover various mysteries of the universe. And that's why this program is based on JWST. Okay? Where it is? James Webb Space Telescope. A question has already been asked by UPSC on JWST, but it was asked in mains examination. 2. Right. At L2 we have JWST. Okay? Next is Square Kilometer Array Observatory, SKAO project. India has become the member of SKAO project, which is located in 2 countries, South Africa and Australia. Right? And we will be getting information again of the universe using these kind of telescopes. Right? Next is INSAT 3DS weather forecasting satellite. INSAT 3DS weather forecasting satellite, which is the orbit where we launch weather forecasting satellites preferably. In mesosphere तो यहाँ है. Satellites, we do not launch satellites in these layers, atmospheric layers. Yes, you are right. Weather forecast, right? But remote sensing satellites are there in low Earth orbit. You have to have a broader picture, and that broader picture you will be able to get when you launch satellites in higher orbits like geosynchronous orbits, or there is a special case of geosynchronous orbit called as geostationary orbit. Right? So weather forecasting satellites preferably, I am saying, it's not a rule, preferably are launched in geosynchronous satellites. It is a feature of geostationary orbit, right? So there is let's say there is a set called as GSO, which stands for geosynchronous orbit, and there is a subset of it called as GEO, which is geostationary orbit, right? So what is the feature of GSO? They take 24 hours to complete one revolution around Earth's orbit, right? Suppose I am an observer and I have observed this satellite in GSO on 18th of May at around 5 p.m. right? So I have observed this object here. Tomorrow on 19th of May at around 5 p.m. I'll be able to see this object again at this particular place, right? So that is a feature of GSO. But if we launch a satellite in GEO, what happens? Which is a special case of GSO. What happens? Suppose I'm an observer on Earth's surface and I've located this object in GEO. For me, this object appears stationary, right? It appears stationary, it is moving, but as observer and this satellite are moving in same speed, it appears that the object in GEO are stationary, and that's why the name geostationary orbit, right? And why this happens? Because the the height at which we launch these satellites is around 36,000 kilometers, and in this particular, or at this particular height, orbital period is 23 hours 56 minutes and 4 seconds. 4 seconds. Polar satellites are different, right? So what are, how to get that page? Fine. So see, there are 3 orbits. There are 3 orbits. First is, I'm not going to discuss in detail. First is LEO, low Earth orbit. Second is MEO, middle Earth orbit. And third is GSO. Fine. Now, these orbits or satellites in these orbits, they move from west to east. They move from west to east, right? So that is what is for these 3 types of orbits. Now there is a type of orbit called as polar orbit. Polar orbit. Fine. If you take height of polar orbit, you can put them under LEO, because LEO from 160 kilometers to 2000 kilometers we have an orbit called as LEO. Right. Height of polar orbits is from 200 to 1000 kilometers. So based on height or altitude, we can place polar orbits under LEO. But what is the difference? Polar orbits are those orbits where satellites move from pole to pole, north pole to south pole and south pole to north pole, right? And as a result of that, what happens? They'll be able to observe more area. Why? Because as they move from pole to pole, Earth beneath them is also rotating, and that's why they'll be able to observe more area, right? And polar orbits, as they are a type of, or as they are a part of LEO, are used for the launch of remote sensing satellites. Fine. Fine. So that is what is polar orbits, and there is a special case of polar orbit called as, there is a special case of polar orbits, it is called as SSPO, Sun Synchronous Polar Orbit. Right, right. For example, a particular satellite is launched in polar orbit and it has appeared over Delhi at 12 noon. Next time, whenever it appears over Delhi, it will be at 12 noon, right? And that's why it is called as Sun Synchronous Polar Orbit. It has synchronized its appearance with respect to Sun. Fine. So that is what is fine. Next now, so that is INSAT 3DS weather forecasting satellite. Next is Kulasekara Pattinam Spaceport. Kulasekar Pattinam Spaceport. Right now we have spaceport at Sriharikota. So it is used for the launch of various kinds of satellites using various kinds of launch vehicles. But this Kulasekara Pattinam Spaceport will be used especially for the launch using SSLV. So it is dedicated for the use of SSLV. Next is Station Shiv Shakti. It is the name that has been given to the landing site of Chandrayaan 3's lander. Next is MethaneSat. MethaneSat is a satellite that is launched by SpaceX. Fine. Next, Chandrayaan 3 and Gaganyaan, these are well known. Fine. So we'll be discussing about them as well, Chandrayaan 3 and Gaganyaan. Then fast radio bursts. Right, fast radio bursts are the burst of radio waves that appear for a very minute time period, and they can be a repository of information about the objects that have produced those radio bursts. Fine. Why they are called as fast? Because they appear only for some milliseconds, but we can get information about different celestial objects using these FRBs, fast radio bursts. day before yesterday, there was an article in the Hindu about the auroras that were seen even in, I think in Ladakh, they have seen auroras. Right? Auroras generally occur at poles. Right? You must have heard about northern light and southern light. Right. Right. So those auroras were seen even in other locations of Earth because of the intense coronal mass ejection that we have seen a few days back. Right? I think around 10th of May, we have seen those kind of CMEs, and those CMEs were intense that led to formation of auroras even at other places of Earth. Right? So go through these kind of articles, they will help you a lot. And that's why newspapers should be your source of information, source of current affairs. Every day, one slot of your study should be dedicated to the newspaper. होता है ऐसा, हो जाता है, फिर से बंद हो जाता है, फिर से स्टार्ट कर. And make sure, means if you have time, make sure you make notes out of it. क्योंकि आज अगर न्यूज़पेपर पढ़ोगे 8-10 दिन बाद वो सब चला जाएगा. So it's better to make notes out of those articles that you read. So next is Pratyush radio telescope. Pratyush radio telescope. This is a telescope that is being planned by ISRO, and this telescope would be placed on. It would be placed on the far side of the moon. Far side of the moon. What is far side of the moon? Which? No, it's not like, it's not like that. See, it is a side that is hidden from us. Moon always shows its this side, its near side to us. Its far side is always behind, always away from us. That side is called as far side of moon. And we are planning a telescope on the far side of moon. Why? Because that area is not, let's say, disturbed by various kinds of radiations, right? And that's why we are planning this Pratyush radio telescope on the far side. Right? Have we ever reached? We means human beings. Have we ever reached on the far side of moon? Lander, not exactly far side, South Pole. Yes, Chang'e of China has reached on the far side of moon. Right? To be more precise, Chang'e 4 of China has reached to the far side. Okay? So that is what is Pratyush. Then other topics are not very important. Next is Kodaikanal Solar Observatory. It has completed some 125 years, and that's why it is in news. Kodaikanal Solar Observatory. Then other space missions of different agencies are there, and then satellite based toll collection system. Have you heard about this satellite based toll collection system?
Yes.
So which type of satellites we will be using for satellite based toll collection? Right, we will be using navigation satellites. Right, we have different types of satellites like remote sensing, navigation, telecommunication, space exploration, etc. Out of all these, we will be using navigation satellites for toll collection, right? And India will be coming up with a pilot project for this kind of thing. Right now, which technology do we use for toll collection? FASTag we use, and FASTags are based on RFID, radio frequency identification technology. It is a near term, not near term. Last year there was one question on this. Which of the following are short range technologies? One option was CCTV cameras, second was this RFID, and one more was there. One more option was there. One more technology was there, and answer was all three. Fine. I think Wi-Fi was there. So these topics we'll be discussing under space. Then under defense, first is high altitude pseudo satellite. High altitude pseudo satellite. So why it is called as pseudo satellite? It's not a satellite, first of all. Right, right. It is a drone powered by solar energy, and that's why it can remain for perpetuity there. Not perpetuity, it can remain there for long time. Otherwise, we have seen that drones are classified based on their endurance time. They can remain there in air for a certain time period, for 10 hours, 20 hours, for 48 hours, etc. They do not have very long endurance time. But these kind of pseudo satellites, which are nothing but a kind of drone, they will be able to remain there in air for a long period of time. Why? Because they are powered by solar energy. So that is what we'll be discussing. Then S-400 air defense missile system. So it is there in news again because we will be using it for certain purpose. S-400. We have procured it from Russia. Right? So next is MQ-9B Reaper. MQ-9B Reaper. What it is? It's also a drone. USA's a drone. Right? Do we use MQ-9B? Agriculture में. See, there are two variants of MQ-9B. First is ISR, that is intelligence, surveillance and reconnaissance, and second is combat. Second is combat. ISR MQ-9B we use it in Indian Navy. We use it in Indian Navy. Fine. But combat one we are procuring, and this article that we will be discussing is related to the combat MQ-9B only. Right. Can you please tell me the treaty because of which we were not able to get access of combat UAVs? Right. Wassenaar technology, which is a dual purpose technology. So it's not Wassenaar. It's not Wassenaar. It is MTCR, Missile Technology Control Regime. Right? Missile Technology Control Regime. Wassenaar is for dual purpose. It is related to, we have discussed this, it is related to cryogenic engines. Right? Russia supplied cryogenic engines for GSLV Mark 1, but thereafter they were not able to supply those cryogenic engines because of Wassenaar arrangement. Fine. But today we are member of Wassenaar, and that's why we can get cryogenic engines from Russia. But we have developed our own. No need to get from Russia. Right? On the other hand, MTCR is a treaty that bans delivery technology, and drones are a delivery technology. Right? Which delivery technology is banned from by MTCR? Which delivery technology is banned by MTCR? That delivery technology which will be able to carry a payload of at least 300 kilograms to at least a distance of 500 kilometers. That delivery technology is banned under MTCR. Right? So these topics we will be discussing under defense technology. Next is health and diseases. Health and diseases. So first is Yaoundé Declaration. Yaoundé Declaration is for malaria, right? So zero death from malaria is the goal of Yaoundé Declaration. We'll discuss it. Next is tartrazine and rhodamine B. Tartrazine and rhodamine B. Have you seen them in news articles? These chemicals? No? You must have read articles related to that candy. Whoa. Which candy? That has been banned in Tamil Nadu, Karnataka. It's a dye, it's a coloring agent, right? And that candy, I don't remember its name. वो बुड्ढी के बाल बोलते हैं ना, cotton candy. Cotton candy. right? Cotton candy and gobi Manchurian has been, means their use has been banned because for the manufacturing of those two products they use these kind of coloring agents and they are harmful. Next is Uvicol S oral cholera vaccine, right? So we have right now a vaccine related to cholera, but Uvicol is a oral cholera vaccine, right? It will help us reduce the dependency on other vaccines. Next is Men5CV vaccine. So these are the vaccines that are in use in the context of Africa, right? Men5CV vaccine. Next is lumpy skin disease. You must have heard about lumpy, right? It is a disease in cattle, right? And have we seen some kind of let's say outbreak of lumpy in India? Yes, last year there was one outbreak related to lumpy. Next is ethylene oxide. Ethylene oxide. Have you heard about ethylene oxide? Where? Right. You must have heard that Everest and MDH masale were banned by Hong Kong and Singapore, and I think day before yesterday by Nepal as well. देख लीजिए, नेपाल ने हमारे एक मसाले बैन कर दिए, right? Because they have found excessive amount of ethylene oxide. Ethylene oxide is used against it is used for antibacterial let's say properties. It is used for antibacterial properties, but its amount has been more in those masalas, and that's why they have been banned. Next is Nipah virus. Which state of India has seen outbreak of Nipah? It's Kerala. Nipah is a viral disease, and it is because of the natural host of Nipah virus is fruit bats. Fruit bats. And if there is a dependency on fruit, on which fruit bats have been have used those fruits, then there may be a jump of this virus from those fruit bats in human beings. Right? Next is HeLa cells. So there was one lady who suffered from a disease and she died way back in 1950s. Her cells were used for various kind of research purpose, and now her family has filed some case against the researchers because their consent has not been taken in the use of those cells. Those cells are called as HeLa cells, right? It is an abbreviation of her name. Okay. Then optical tweezers. Optical tweezers are is a technology which can be used in order to manipulate atomic and subatomic particles. Right? To manipulate atomic and subatomic particles, we use this technology. We'll discuss about that. Then after health and diseases, the next topic that we will discuss is battery energy storage systems, BESS, and lithium ion batteries. Right? We have some battery energy storage system, because you must be aware the most important problem with respect to the use of renewable energy is that it cannot be stored. Means its storage is difficult, but if we have that kind of storage, it would be easier for us to scale up use of renewable energy, and that storage is there in India now in the form of BESS, right? And then we will have a discussion on lithium ion batteries as well. And then India's indigenous fast breeder reactor, FBR. India's indigenous fast breeder reactor. Fast breeder reactors, do we use fast breeder reactors in Indian nuclear program? At which stage? If yes, at which stage? Third stage. Do we use fast breeder reactors in Indian nuclear program? Yes, fine. So, pehla hoga. At which stage? थोरियम को क्या कर? First stage में do we use thorium? Thorium we cannot use because thorium is not fissile. Thorium is fertile in nature. Right? On its own, thorium cannot set in nuclear fission reaction. Yes, uranium we use in the first stage, natural uranium. First stage is PHWR, pressurized heavy water reactor stage, PHWR stage. Second stage is FBR, fast breeder reactor stage, and third stage is experimental. It is called as advanced heavy water reactor stage, where we use thorium. Right? In third stage, we use thorium. So, not exactly in third stage, we start using it in the second stage, second part of stage 2 itself, but third stage is totally dependent on thorium. We will discuss that. So, these are the topics that we are going to discuss in our today's class. So, let us start with first topic, and that is information and communication technology. Under that, first is submarine cable system. So, why it is in news? Why it is in news? So, some incident has happened, and that incident is unknown incident as of now. Means Western countries have blamed Houthis that they have damaged those submarine cables, but Houthis have blamed Western countries that their missiles have damaged those cables. Right? So, an incident in the Red Sea has resulted in damage to 3 submarine cables. First is Asia, Africa, Europe 1. Then second is Europe, India Gateway, and third is Tata Global Network. You don't need to remember these names. Fine. So, submarine cables have been damaged, and submarine cables are a kind of optic fiber cables that are used for establishing communication between 2 locations. Right? For example, right now in Wi-Fi and all, in broadband internet, we use optic fiber cables. You must be aware of BharatNet project as well. In BharatNet project, what we are doing, we are connecting 1,50,000 and more gram panchayats so that they will be able to have access of internet, and for that we use optic fiber cables. Can you please tell me the principle on which optic fiber cables work? They work on total internal reflection. Right? We have discussed these things, total internal reflection. And what happens because of TIR?
Almost near to the light
Right.
while bending also it does not.
Right. So, the most important property of optic fiber cables is that they are based on a principle of total internal reflection that allows them to use light for establishing communication between 2 locations. Right. So, because of total internal reflection, whatever light that is flowing through this optic fiber cable, it does not escape, and that's why there will be no leakage of data. Right? Whatever light we are using for transmission of data, that light remains inside the cable because of total internal reflection. Right? So, that is what is optic fiber cables, and these optic fiber cables or these submarine cables have been damaged in Red Sea. Next. So, submarine cables are fiber optic cables laid on the ocean floor that connect countries across the world to provide internet and telecommunication services. What is the significance of these submarine optic cables? They carry around 99% of the world's intercontinental internet traffic. Right? So, that is an important point. 99% of internet traffic is through these submarine cables. The United Nations General Assembly, UNGA, has declared SMCs, that is submarine cables, as critical communication infrastructure. Right? So, this point is important. Critical communication infrastructure. Right? And in internal security, you must have gone through GS3 paper syllabus. Under that, there is a topic of internal security, and under internal security, there is one subtopic, and it is related to critical infrastructure. Right? Critical infrastructure is that kind of infrastructure which is important for the functioning of that particular country. Right? For example, power grid is a critical infrastructure. Even telecommunication lines is a critical infrastructure. Fine. So, UNGA for the global community has declared these submarine cables as critical communication infrastructure. Next. Next is, so in India, India has 17 international SMC landing at 14 cable landing stations CLS in 5 coastal cities. Right, we have 17 international SMCs, submarine cables, landing at 14 cable landing stations. Cable landing stations you can consider as ports. Right, at ports we receive ships that are carrying various kinds of goods. These cables are received at these 14 cable landing stations, and those are there in 5 different cities in India. But Mumbai and Chennai have maximum concentration of these SMCs. Right. India has also domestic submarine cables such as Chennai, Andaman and Nicobar Island cables, CAN, Chennai, Andaman and Nicobar cables. Then second is important, it is Kochi, Lakshadweep Islands submarine optic fiber connection, KLISOFC. Right, so this is in news, Kochi, Lakshadweep Island submarine optic fiber cables. So it was inaugurated in January 2024, and that's why it is important. Fine, it was inaugurated in January 2024. Significance: for the first time since independence, Lakshadweep is connected through submarine optic fiber cables. Fine. It is funded by this submarine cable that connects Kochi and Lakshadweep. It is funded by Universal Services Obligation Fund, USOF, under Department of Telecommunication. Can you please tell me what is USOF? Universal Service Obligation Fund. Right. Not under Telecom Act, under Telegraph Act. 1885 something. Fine. So, Universal Service Obligation Fund is a kind of levy imposed on telecom service providers. And that revenue is used for establishing communication networks in rural and these areas which are under Naxalite. And so USOF, it is a statutory fund established in 2003 under Telegraph Act of 1885. 1885 or 1858, you just confirm that year. I think 1858 only. Okay? And using that fund, this submarine cable connecting Kochi and Lakshadweep has been established. Next, project executing agency is BSNL. This project has been executed by BSNL. Okay? So that is first topic. What is the important information? Important information is related to this KLR. Right? And this submarine cables, they are critical communication infrastructure as per UNG. Next. So that is first topic. So these are the lines of submarine cable connectivity in India. So Chennai to Andaman and Nicobar, and then from Kochi to islands of Lakshadweep. Fine. Next is free space optical communication. Free space optical communication. So why in news? So Alphabet's project. Alphabet is a parent company of Google. Alphabet's project Tara, is deploying light beam internet technology in India, Africa and other regions. Project Tara uses free space optical communication, FSOC. This is very important from this year's exam. FSOC, free space optical communication. Why it is called as free space? Because there are no cables. We are not using cables, means under Project Tara they will not be using cables, and that's why it is called as free space. And optical communication means it is a type of communication that is based on light radiations. Right now, which waves do we use? We use radio waves. Even in our mobile phones and all, for communication we use radio waves. But here they will be using they will be using optical radiations, visible radiations, and you must be aware of electromagnetic spectrum. What is the feature of optical radiations compared to radio waves? So this is, let's say, electromagnetic spectrum. So let us consider that this is electromagnetic spectrum. So radio waves have, they have highest wavelength. Gamma radiations have highest frequency. Right? More the frequency, more is bandwidth. And more the bandwidth, more data can be transmitted. Fine. So radio waves, they have low frequency, and as a result of that, they won't be able to take huge volume of data. Fine. On the other hand, visible, which is also called as optical, visible or optical, same, they have more frequency. They have more frequency compared to radio waves, and that's why data can be carried by optical radiations, and that data would be more than radio waves. And that is what is the feature of these optical radiations. Fine. And that's why they want to use these optical radiations under Project Tara. So Airtel will be partner in this. Airtel will have its own setup, and that setup will be receiving those signals, those visible light signals from the Project Tara, and from that setup it will be routed to different areas. That is what will be happening under this Project Tara. Partner of Google or Alphabet in this project is Airtel. Okay. Next, FSOC, an outdoor optical wireless communication technology. It is an outdoor optical wireless communication technology. It requires a clear line of sight. So this is one of the problems. This is one of the problems with respect to the use of optical radiations. You need a clear line of sight. If there is any obstacle in the line of sight, it won't be able to establish communication. Yes, fog, heavy clouds, it means under those kind of things, it will not work. Right? So there are challenges, we will discuss about that. No, Starlink uses satellites. Starlink uses satellites, and those satellites use radio waves. Okay, so Starlink is not based on optical radiations. Sorry.
In this one, there will be one source in the satellite.
In Project Tara, yes. Yes. Right. Yes, that will be based on radio waves. See, from that particular, let's say, satellite to ground station, it will be light radiation, and from ground station to different, let's say, users, it will be based on radio waves. In Starlink, there are ground stations, but the data that is coming from satellite to those ground station is radio waves. It's not optical radiations. The difference between Starlink and this Project Tara is that in Project Tara, optical radiations are used for establishing communication between satellites and ground stations, but in Starlink, there are radio waves that establish communication between satellite and ground station. Okay? Next, data transmission achieves data, voice and video communication with up to 10 Gbps data rate via full duplex technology, for full duplex connectivity. What is full duplex connectivity? Right. So right now means not in 5G. Have you started using 5G? No. So fine. In 4G, you must have observed that whenever you talk with your friend, you have to take turns. ऐसा नहीं कि दोनों साथ में बात कर रहे और you will be able to understand that communication. ऐसा नहीं होता. क्यों नहीं होता है? Because in up to 4G, we did not use full duplex. Full duplex has been introduced in 5G, right? And that's why what happens for 4G or till 4G, we have to take turns. Suppose if that person is talking, we'll have to wait. If you are talking, that person will have to wait. But in case of full duplex technology, full duplex connectivity, there will be movement of data in the bidirectional manner. And that's why both the person can talk simultaneously under full duplex technology, which is also a part of 5G. Okay? So in this FSOC will be using full duplex connectivity as well. Next is free space optical communication. So principal working similar to optical fiber cables, however, it uses free air instead of glass fiber cores. So this point we have already discussed. Fiber optic cables use glass fiber cores, right? But in case of FSOC, it is free air. There are no cables. Application: providing internet access to remote areas, right? Even for Project Loon, objective was to provide internet access to remote areas, and in Project Tara also the objective is to provide internet access to remote areas. So that is about FSOC, an important topic. Project Tara. FSOC is nothing but Project Tara. Any doubt? And you can even add this point. Deep space optical communication demonstrated by NASA. Deep space optical communication demonstrated by NASA. Fine. And one more is there. It is LCRD, again by NASA. Laser communication relay. Laser communication relay demonstration. Laser communication relay demonstration. Right. So what is the difference between DSOC and LCRD? Difference is that in DSOC, deep space communication has been demonstrated, and in LCRD it was not deep space, it was from low Earth orbit. It was from low Earth orbit. That is the difference between DSOC and LCRD. Okay? Next. So benefits and challenges of free space optical communication. What are the benefits? It is cost effective. It is cost effective to use FSOC. Then quickly deployable, right? We can deploy it quickly. We don't need large setups for FSOC. High speed data transmission, we have already discussed. It is 10 Gbps. 10 Gbps of speed we'll be able to get. Fine. So those are the benefits. What are the challenges? Signal reliability is affected by fog, haze, and other atmospheric conditions. Why? Because light is being used, right? And as light won't be able to pass through these kind of atmospheric features, signals will be affected. Next, interference from physical obstructions like birds, right? So this is also a problem. If birds are flying, and you must be aware birds generally fly in groups, so if that is the case, again signals will be disturbed. Next, requires advanced mirror controls and motion detection, right? We use various kinds of mirror controls for FSOC, and motion detection technology is also used for FSOC. That technology is used in the setup, in the ground station setup. Fine. So it requires this kind of advanced technology, and that's why cost of this technology may rise. Cost of FSOC may rise. So this is getting nullified because of the use of mirror control and motion detection technology at the ground stations. And so those are the challenges. Next, similar kind of initiatives are there. Project Loon, which we have already referred to. It was also Alphabet's previous initiative using stratospheric balloons for internet connectivity. In the stratosphere, they wanted to establish these balloons, and through those balloons they wanted to provide internet services. And this question was asked by UPSC in 2016's prelims examination. Next, Starlink. Starlink, you must be aware, it is SpaceX satellite-based internet service for remote areas. Fine. Can you name other similar project similar to Starlink? One more project is there which is very famous. Few more are there, but the second one is famous. It is OneWeb. OneWeb, where Bharti Internet is a partner. OneWeb initiative. Jio is also coming up with this kind of project. Fine, so that is about free space. Sorry? Can you please tell me, are they same or different? You are talking about FSOC, that is free space optical communication, and DSOC, right? Deep space optical communication. See, what is the similarity? Both are using optical radiations for communication. What is the difference? This is from low Earth orbit based satellites, and this is from deep space spacecrafts. Fine, and its purpose is to provide internet services to remote areas. And what is the purpose of DSOC? This demonstrated by NASA for what purpose? For data transmission, for space exploration. Here we don't want to provide internet service. NASA is not trying to provide internet service under DSOC. Under DSOC, they wanted to establish communication between Earth's ground stations and deep space telescope satellites that they have launched. Okay, वो जो telescopes है, for example JWST, they are coming up with huge amount of data, and that data, it is means वो समा नहीं रहा है इसमें radio waves में. Radio waves are not able to occupy that data, are not able to transmit that data, and that's why optical waves are being demonstrated, not use, demonstrate. Okay, so that is the difference. ISRO may use in future. See, right now there is no problem with radio waves. Radio waves are working absolutely fine. Right, only the data that they carry is limited. So tomorrow, when we launch many more space exploration satellites, we have to have a technology that will be able to carry more amount of data. Fine. तो उसके लिए ये demonstration experiments है सिर्फ. अब right now we are not using these kind of things. Right now we are still using radio waves. Clear है? Next is near field communication NFC technology. So why in use? The National Payment Corporation of India, NPCI, has initiated the deployment of UPI tap and pay feature. So with UPI also you'll be able to tap and pay based on NFC technology, and that has been introduced by NPCI, National Payment Corporation of India. So what are the key points? NFC, that is near field communication, uses electromagnetic radio fields to share information between two compatible devices within a short range. What is the range? 4 to 5 centimeters only. Right? That means you almost have to touch. You almost have to touch your let's say NFC enabled device with the platform. Fine. Next, comparison with other technologies. So there are other technologies that are also used for data communication. First is RFID, that is radio frequency identification. So its range is 100 meters or more. Fine. The RFID technology we use in FASTags. Fine. Even RFID is used in shopping malls. You must have seen on clothes they have those dark color, black color or gray color tags. In those tags also RFID technology is used. Fine. Next, Bluetooth, usually within a range of 10 to 100 meters. So ये भी बहुत ज़्यादा है. It's not 10 to 100 meters. It's up to 10 meters. It's not 10 to 100. Fine. Bluetooth. Next is infrared. Infrared is a short range, a few meters, requires line of sight and mainly used for remote controls. Right? In remote controls, which technology do we use? We use infrared technology. Fine. And it is also a short range. It works only for a few meters. Right? And you need to be in the line of sight. You need to be in line of sight for establishing communication between two devices using infrared. So that is what is NFC. So there are some components of NFC and working process. Firstly, we'll discuss working process. So an NFC compatible device emits radio frequency signals. Fine. For example, NFC is also used in metro cards. Right? In metro cards we use NFC. Your cards have a chip, or you can consider it as a kind of tag. Right? And there is a scanner on metro stations. Those metro station scanners emit radio frequency signals. Radio signals they emit, and that allows your tag, means your card, to capture those radio signals, and that leads to generation of a small electric current in your card. And as a result of that, there will be establishment of a magnetic field. Magnetic field will be established between your device, your card, and that scanner on the metro station. That magnetic field will allow data transmission from your card to the scanner on metro station. Right? And as soon as you remove the card, magnetic field will vanish, and as a result of that, the person who is standing behind you will be able to use his or her card immediately. There is no need to wait in case of NFC. Why? Because magnetic field is used to establish communication, and magnetic field vanishes very quickly, and that's why in metro cards we use this kind of system. Fine. And this system we are even using in these tap to pay features, because once you tap your card against a machine, against NFC enabled machine, data communication should happen only for a small time period. It should not be there for longer time period. Otherwise, what will happen? Your card will be used for paying someone else's payment. So to avoid that, we use NFC, because NFC is a technology that uses magnetic field induced communication. Clear? So an NFC compatible device emits radio frequency signals. These signals interact with NFC tag, creating a current that facilitates communication. This current, what it does? It leads to production of magnetic field. If magnetism is induced as a result of electric current, that magnetism is called as electromagnetism. Fine, it is called as electromagnetism. And that's why we can say that for NFC we use electromagnetic radio signals. Okay? Next, the NFC tag is passive. The card is passive. What do we mean by that? Passive. It only sends information. It cannot read it. It can only share its information, right? And that's why it is passive. The other device, that means the scanner on, let's say, metro station. The other device, like a smartphone, is active. That means it sends and receives information, right? So this point is important. These 2 points, last 2 points are important. NFC tag is passive. NFC tag is passive. That means it only sends information. And NFC enabled device is active. That means it can send as well as receive information. Clear this point? Next now, applications. So what are the applications of NFC technology? There are a number of applications. First is in contactless transactions, which we have already discussed. Second is in security, right? In security, why in security? Because communication fades within seconds. So secures network and buildings, monitors inventory and sales, prevents auto theft. So auto theft may occur because of the prolonged communication. So that is not there in NFC, and that's why it can be used to prevent auto theft. And operates unmanned toll booths, right? In toll booths also, but this kind of thing is not used in India. But in future, NFC can be used for toll booth, on toll booths as well. Which? It's infrared, because it is a kind of remote control only, right? Next, consumer electronics, present in speakers, household appliances and other devices controlled by smartphones. Healthcare in wearables, wristbands. That means in wearable wristbands, we can use them to monitor the critical information of patients. Fine. And lastly, for wireless charging, it facilitates wireless charging of devices as well. NFC. Yes, NFC is used for wireless charging. You must have seen those platforms. You just have to keep your smartphone on that platform, right? So that is what is wireless charging, and in wireless charging we use NFC. So 3 applications you can consider more important. First is tap to pay feature. Second, metro cards. Third, wireless charging. These are the important applications which we have already started using NFC. Okay? And one question was already asked by UPSC on NFC way back in 2015. But these kind of things get repeated, right? Because the application is new. Tap to pay application is new application. Next, supercomputers. Supercomputers, we have already referred to supercomputers. So supercomputers, as we have already discussed, they work on the principle of parallel computing. What is parallel computing? what happens in parallel computing? A problem is divided into number of sub problems, and those sub problems will be assigned to various CPUs, various processors. Those processors will solve those sub problems, and at the display their outcomes will be combined and they will be displayed together. That is what is called as parallel computing. Fine. It's like, suppose you go for shopping, and you are a group of four, let's say you are a group of 4 person. So what you do, you divide stuff that you have bought amongst you, and you 4 go to different billing counters. That is what is parallel computing. Okay. Next, so why we are discussing supercomputers? India's AI supercomputer Ahlawat has been ranked 75th in the top 500 global supercomputing list. You don't need to remember rank, but this is the fastest supercomputer that we have ever built, because no other supercomputer has entered in the top 100 list from India. Next, about supercomputers definition: high performance computing systems with exceptional processing powers and computational capacity are supercomputers. How do we measure their performance? We measure their performance in flops. What do we mean by flops? Floating point operations per second. And what are floating point operations? Decimal operations. Decimal operations are called as floating point operations, right? And traditional devices like these, how do we measure speed in these devices? We measure it in MIPS, million instructions per second. How many instructions they are able to process? That is called as million instructions per second. So in the programming of processors, we have various kinds of instructions. For example, move P1 to P5. So this is a command: move data present at the port 1 to port 5, right? Then add P5 with P2, for example. So these are the kind of instructions that we have in the processing of processors, microprocessors, right? So how many such instructions are processed in second? That is what is the speed of the traditional computers. Next, India's supercomputers in top 500. First is Ahlawat. Second is Paramsiddhi AI. Next is Pratyush. Next is Mihir. These are the top supercomputers that we have in India. Next. Where this Ahlawat is placed, where it is located? It is located at CDAC Pune, Center for Development of Advanced Computing, Pune. What is the speed? Its speed is 13,170 teraflops. 13,170 teraflops. In petaflops, you can write speed. In petaflops, speed is 8.5 petaflops. And 13 petaflops is the speed. This is our max speed and this is our peak speed. R max and R peak. Okay. And 1 petaflop is equal to 10 to the power 15 flops. 10 to the power 15 flops. Okay. What is R max and R peak? What is the difference between them? It's not like that. It's the claimed mileage and actual mileage. how much is claimed by the company and what do you get in reality. Okay, so that is what is the speed. Purpose. It is a part of National Program on Artificial Intelligence (NPAI), and under means this NPAI, which is a program under Ministry of Electronics and IT. We use this Ahlawat to leverage AI for inclusion, innovation, and social impact. Right? You must be aware there was one document given by Niti Aayog way back in 2018. It is a white paper on the development of AI in India, and it is also called as National Strategy on Artificial Intelligence. National Strategy on Artificial Intelligence given by Niti Aayog. And in this strategy, they have used one hashtag, and that hashtag is AI for all. AI for all. So this NPAI, which is a program under Ministry of Electronics and IT, it is also working for use of AI for inclusion, innovation, and social impact, so that the benefits of AI can be reaped by everyone. Right? So that is what is the objective of this NPAI. Okay? And it is on the lines of this objective of NPAI is on the lines of the objective of NSAI, which is a white paper. White paper means means how AI should progress in India. That white paper was given by Niti Aayog, and it is a national strategy for AI. Next now. Clear this point? So before we move to the next part, that is 3D printing, there is one mission which you must be aware for supercomputers. Can you name that mission? Right. National Supercomputing Mission is a mission under Ministry of Electronics and IT, and it is taken ahead by CDAC Pune and IISc Bengaluru. Right. And what is the objective of this National Supercomputing Mission? No, it's not like that. See, supercomputers are already there, right? For example, there is another mission called a National Quantum Mission. No. See, for the technology that is not established, you can say that the mission is related to ecosystem. But supercomputers technology is established technology. You just have to come up with superior supercomputers. So under NSM, National Supercomputing Mission, objective is to come up with 70 to 72 supercomputers and establish them in various academic and research institutes of India, and also to form their network. We want to establish their grid so that the collective computational power of those supercomputers can be used simultaneously. Right? And many such supercomputers have been established in various parts of India, in various academic and research institutes of India. You must be aware Param Brahma, Param Siddhi, no, not Param Siddhi, Param Brahma, Param Yukti, Param Sanganak, all these kind of Param Shivai, these kind of supercomputers have been established in various institutes. IIT, let's say Roorkee, IIT, BHU, IISc Bengaluru, all these institutes have these kind of supercomputers. Fine. So that is National Supercomputing Mission. Next. So that is about supercomputers. Next is Next is 3D printing. So 3D printing, keyword is, it is an additive manufacturing. It is an additive manufacturing process. Additive manufacturing is different from subtractive manufacturing, and for 3D printing, we need first 3D model or image of the object that we want to manufacture. Suppose you want to manufacture this mouse. So what you need a 3D model of this mouse. Fine. And how we get this 3D model? Right, there are softwares. For example, AutoCAD software. Right. Second, you need slicing software. Slicing software. So once you have this 3D model, this 3D model needs to be cut down into pieces so that we can use additive manufacturing, right? So that cutting down into pieces is done by slicing software. What slicing software will do? Will divide this file. Let us consider that this 3D model or image is a file. This file will be divided into number of files by slicing software. Fine. And once we have these files, what we do? We use 3D printer. These files will be fed to 3D printer, and this 3D printer will execute these files one by one. Suppose it executes first file. So what will happen? First layer of raw material will be laden. Second file is executed, then second layer of raw material will be laden. Similarly, it will lay the raw material till the time you get this mouse. Fine. So that is what is 3D printing, and that's why as it is laying down the layers of raw material one by one, it is called as additive manufacturing. Fine. So why in news? Researchers at IIT Mandi have found that the extrusion based metal additive manufacturing process is a cost effective method compared to the other 3D printing approaches, right? So a new approach for 3D printing has been found by the researchers at IIT Mandi. Next, 3D printing slash additive manufacturing. It is a process where a digital model, that is CAD, is turned into a tangible 3-dimensional object by laying down successive thin layers of raw materials. Which type of materials we can use? We can use plastics, we can use resins, thermoplastics, metals, fibers, or ceramic kind of materials we can use for 3D manufacturing. Can you name 3 materials which we cannot use for 3D printing? Fine, paper we cannot use. Wood we cannot use. And one more. Cloth or textile we cannot use, right? These raw materials we cannot use for 3D printing. Fine. Next is comparison to traditional manufacturing. Unlike subtractive manufacturing, which removes material, 3D printing adds material layer by layer, and that's why it is called as additive manufacturing. Benefits. What are the benefits? First, lower inventory cost. That means you don't have to have, let's say, lots of stock. It is print on demand. Whenever demand is there, you can print. Fine, and that's why you don't have to maintain high inventory, and that's why lower inventory cost is there. Reduce production time, right? It is relatively faster process, especially for prototyping, and that's why most of the prototyping that is done in the manufacturing sector is today based on 3D printing. Okay. Next, ability to print complex designs. Right? This is also an advantage. If there is a complex design, for that complex design, using traditional manufacturing, you will have to come up with a very complicated mold. right? Molds are there for traditional manufacturing. So you need those complicated molds for the let's say complex designs. That mold manufacturing itself will be very costly. It will take lots of time. So that kind of thing we can replace using 3D printing. So 3D printing has an ability to print complex designs as well. Next, minimal wastage of materials, and that's why it is environment friendly. And that's why it is environment friendly. Fine. Can you tell me some disadvantages? Some disadvantages of 3D printing. Fine. So,
Very slow also. 3-4 days it will take.
3-4 days it will take. See, the most important problem is that it is a kind of automation, and that's why it would replace lots of jobs, right? Lots of jobs will be taken by 3D printing if used on a very large scale, right? So that is one. Second is the 3D printed material or the raw material that we use for 3D printing, most of the times it is non-recyclable. It's non-recyclable. And that's why this advantage is getting nullified. Also, they say that the material that we use in 3D printing is not of food grade. Food grade material is not there. And that's why if we have, let's say, lunch boxes manufactured using 3D printing, it cannot be used for that kind of application. Food based applications are not possible using 3D printing. Okay? So these are some of the challenges that we have of 3D printing. Now one more point I would like to add here, and that is of 4D printing. What is 4D printing? Right. So simply put, 4D printing is 3D printing plus smart materials. What is 4D printing? 4D printing is 3D printing plus smart materials. What are smart materials? Smart materials are those materials which can adjust based on external stimuli. That stimuli may be of temperature, pressure, or any other stimuli. Right? Based on that, they will be able to adjust with their let's say shape. Fine. So that is what is 4D printing. 3D printing plus smart materials. Next now. So this is theoretical part. We'll just go through this. India AI mission. So the Union Cabinet has approved over rupees 10,300 crore for the India AI mission. About India AI mission, its aim is to establish an AI innovation ecosystem through public-private partnerships, deploy over 10,000 GPUs for advanced AI computing infrastructure. What is GPU? Graphic Processing Unit. So these GPUs, they are also used in supercomputers, and as a result of these GPUs, what happened? The processing of data happens in a short span of time. Fine. And you must be aware, without data, we cannot come up with AI. Right? Raw material used for artificial intelligence is data. But that data needs to be, that data should be converted into, should be transferred into information, and that is being done by GPUs. Fine. And that's why we will be using these 10,000 GPUs for advanced AI computing infrastructure. Then promote responsible inclusive growth of India's AI ecosystem. Again, it is AI for all. Next, ministry. Which ministry is carrying out this mission? It is by Ministry of Electronics and IT. Then funding is over 5 years through a public-private partnership model. and implementing agency is India AI Independent Business Division under Digital India Corporation, DIC. Right, so there is separate India AI, there is separate India AI Independent Business Division under Digital India Corporation. That will be the implementing agency of this particular mission. Right, so factual information, you will have to remember this. Next, so this Digital India Corporation. So about Digital India Corporation, DIC is a not-for-profit company set up by the Ministry of Electronics and IT under Section 8 of the Companies Act 2013, not important information. Earlier this DIC was known as Media Lab Asia. It was known as Media Lab Asia. The company has been renamed as Digital India Corporation in 2017. So various projects have been undertaken by this DIC. First is AINA Dashboard for Cities. AINA Dashboard for Cities for Ministry of Housing and Urban Affairs. So do you know what is this AINA Dashboard for Cities? It is a kind of application that can be used by various cities to assess their performance. Right, you must be aware there are various kinds of performance based ranking for various cities, and that they can assess their standing in this particular dashboard. Okay, so that is AINA. DigiLocker, you must be aware. What is DigiLocker? It is a digital document wallet. It is a digital document wallet. DigiLocker. Then next is India Stack. India Stack. Do you know what is India Stack? What it is?
Data systems like it can be just plug and play.
See, it is a set of APIs. Application. Sorry. APIs you must be aware, it allows, for example, suppose you scanned some QR code. So based on that, or let's say you are using some app and there is a payment feature in that app. So for payment you chose, let's say, Google Pay. So from that app on which you are paying, you will be taken to Google Pay. So that is inter application, let's say, communication. That inter application communication is called as API, application programming interface. Right. So this India Stack is a set of these APIs, application programming interface. Next is Meri Pehchan, National Single Sign-On. So what it is? It is a user authentication service in which a single set of credentials provide access to multiple online applications or services. Right, so means you will be able to log in at a particular in a particular application, and through that application you will be able to access all digital services. So that is what is Meri Pehchan. Next is OpenForge. What is OpenForge? It is Government of India's platform for open collaborative development of e-governance application. Now this is open source, right? This is an initiative of Indian government for development of open source applications. And you can write down this point. A platform to promote use of open source softwares. A platform to promote use of open source software. Okay. Next is Potion Tracker. Potion Tracker. So it is a kind of app that provides 360-degree view of the things happening in Anganwadi centers. Right? All the tasks, all the works that are being performed in Anganwadi centers, their 360-degree view we can get from Potion tracker. So these projects have been undertaken by DIC. So these projects are important. These projects are important, if not DIC. Next is also not very important. 7 independent business divisions under DIC, not important. Next now we'll be discussing about space technology. So before we move, if you have any doubt under ICT, you can ask. If you have any doubt under ICT, you can ask. No doubt? So let us discuss space technology. First is Pushpak reusable launch vehicle. Pushpak reusable launch vehicle, RLV, LEX-02. So LEX is a second experiment that has been carried out for the development of reusable launch vehicle. So why it is in use? So ISRO successfully conducted the Pushpak reusable landing vehicle LEX-02 landing experiment. What is RLV LEX-02? Is a part of the reusable launch vehicle technology demonstration program, RLV-TD. So RLV-TD is a technology demonstration. What do we mean by that? In this technology demonstration, ISRO has demonstrated that yes, they also can come up with reusable launch vehicles, and this they have done way back in 2016. But only single test, based on single test, is it possible for us to develop reusable launch vehicles? No. We have to carry out multiple testing, and that is being done under these experiments. Okay. Next, revalidated. So what LEX has done, it has revalidated indigenously developed technologies for high-speed autonomous landing of a space returning vehicle. Because those vehicles that are returning, they are coming at a supersonic speed, and that's why there is a need to control those vehicles to ensure that they land safely, and that is being done under LEX-02. Next, RLV-TD program, it aims to develop essential technologies for a fully reusable launch vehicle, that is a vehicle that can travel to low Earth orbits to deliver payloads and return to Earth for reuse. Fine. And these kind of launch vehicles will be different from PSLV, GSLV, SSLV, which are expendable launch vehicles. Right. Next, global context. So globally, NASA had used reusable launch vehicles earlier, but today it does not have reusable launch vehicles because most of its launching has been done by private agencies like SpaceX. So SpaceX has a reusable launch vehicle, but it is partial reusable launch vehicle. Fine. So SpaceX has partial reusable launch vehicles with it. What is partial reusable launch vehicles? That means it will need some kind of refurbishment. Right. For example, that RLV has landed, immediately we cannot use it for next launch. We'll have to carry out some kind of refurbishment, and that's why it is called as partial reusable launch vehicle. Okay. So that is what is Pushpak. So naam yaad rakhna. Next is X-ray polarimetry or X-ray polarimeter satellite, XPOSat. It was launched by ISRO on 1st January 2024, this year. It is a second astronomy satellite of ISRO. Can you name first one? It is a second astronomy satellite. See, there is a AstroSat. So there is a category so satellites based on their application are categorized into different types. First is remote sensing. Second is navigation. Third is telecom, right? And fourth is space exploration. Space exploration, right? Space exploration satellites have one category, and it is called as astronomy satellites. Now, what is the difference between other space exploration satellites and astronomy satellites? What is the difference? Difference is that these space exploration satellites, they go beyond right. For example, MOM, Mars Orbiter Mission, Chandrayaan, they have gone beyond Earth's orbit, and that's why they are true space exploration satellites. But there are other satellites which remain in Earth's orbit and carry out space exploration, right? So for example, suppose this is Earth. A remote sensing satellite is launched, and this remote sensing satellite will face towards Earth. Astronomy missions, what they will do, they will also be there in, let's say, Earth's orbit. Let's consider that they are there in LEO, low Earth orbit. But instead of focusing towards Earth, what they will do, they'll focus towards the space, towards the universe, so that they can capture information about the universe. Fine. So that is the difference between space exploration and astronomy satellites. Clear? Aditya L1 is space exploration. Aditya L1 is beyond Earth's orbit. It's there at L1, which is almost 1.5 million kilometers away from Earth. Okay? So we have two astronomy satellites. Second one is XPOSat, which we are discussing right now. And first one, on which UPSC has already asked a question, is AstroSat. AstroSat was launched in 2015, and it was for collection of information in optical, UV and X-ray bands simultaneously. Collection of information in optical, UV and X-ray bands simultaneously. It was launched in 2015. It was the first astronomy satellite launched by ISRO. Where it is? It's there in low Earth orbit, around 670 to 690 kilometers orbit. Okay? So that is what is AstroSat. So let's discuss this XPOSat. So ISRO successfully launched X-ray polarimeter satellite XPOSat by the use of PSLV. Using PSLV. About XPOSat, it is an ISRO planned space observatory to study the polarization of cosmic X-rays. Cosmic X-rays means from various sources. X-rays are coming from various celestial bodies. X-rays are coming. Those X-rays emitted by those sources, when they travel towards us, they get polarized. They get polarized by the matter present in the universe. And as a result of that, we are able to see, we collect those X-rays, but we get information about the matter from which it is getting polarized, but not the source. And that's why we need to know the polarization, so that we'll be able to understand the source that is emitting it. Right? And that's why this XPOSat has been launched. Objective: to study the 50 brightest known sources in the universe, including pulsars, black holes, X-ray binaries, active galactic nuclei and non-thermal supernova remnants. Are you able to understand these terms? What are pulsars? डिस्कस किया है हम लोगों ने पल्सार्स नहीं किया है. So when star dies, it has two options to die. उसको option मिलते हैं. Right. क्या बन जाएगा? Neutron star. 1.6. No, 20 times. 20 times. कहाँ पे? Chandrasekhar limit. No, it's 20 times. Means this information is there on NASA's website. Okay? So when star dies, it has two options. One, it can become a neutron star or it can become a black hole. So when its mass is huge, that means more than the mass of our sun, at least 20 times more than the mass of our sun, it will become black hole. If mass is less, it will become a neutron star. Right? There are two types of neutron stars based on magnetic field. Right? If the magnetic field is very strong, that neutron star will be called as magnetar. If magnetic field is less, it will be called as pulsar. Okay, so what is pulsar? It is a kind of neutron star with little lesser magnetic field. Then black holes. Black holes, what are black holes? Right. Fine. So when star dies, it becomes a kind of black hole, and these black hole are the cosmic objects which have very strong gravitational pull, and as a result of that, nothing, not even light, comes out of these black holes, and that's why they are called as black holes. Fine. We have discussed these. You can go through those slides. We have discussed these things in detail. Then X-ray binaries. What are X-ray binaries? X-ray binaries are nothing but binary stars. They orbit around each other and they emit X-rays, and that's why they are called as X-ray binaries. Then active galactic nuclei. Active galactic nuclei is the center of some bright galaxies, right? And those bright galaxies, they emit X-rays. Then non-thermal supernova remnants. What is supernova? Right, it is an event that leads to death of star. Death of star event is called as supernova. In that event, there may be production of some non-thermal remnants. Those non-thermal remnants may produce X-rays. Those X-rays can be collected using this XPOSat. Right. So simply put, XPOSat will be collecting polarized X-rays from these different celestial sources, so that we can study these sources. Next, orbit. What is the orbit of XPOSat? It is low Earth orbit. Next, it is a joint effort of ISRO and the Raman Research Institute, Bengaluru in Karnataka, after NASA's Imaging X-ray Polarimetry Explorer. This point is important. After NASA's Imaging X-ray Polarimetry Explorer, which was launched in 2021, it is the only second polarimetry mission in the world to use X-rays. Fine. So this is the second mission. First is by NASA, and it is IXPE mission. Okay. Next. Next is Uncover program of JWST. So why in news? Researchers, as part of the James Webb Space Telescope Uncover program, have found a clue about the end of the dark ages in the early universe. Right. So what is the dark age in the early universe? Right. So after Big Bang, the light was produced, but that light was not able to pass. It was not able to spread. And that era when light was not able to spread is called as dark age. And why it was not able to spread? Because of the dense fog of neutral hydrogen gas. Right? This hydrogen gas was blocking the light, and that's why there was darkness in the universe, and this era, this time is called as a dark age of the universe. Right? So it is a period when light sources were obscured by the dense fog of neutral hydrogen gas. It was followed by the epoch of reionization. Epoch of reionization marked by the emergence of first stars and galaxies. In this, see, when Big Bang happened, firstly Big Bang happened, then we had a dark age, and after dark age there was one new, let's say, new time, and that is called as epoch of reionization. And under this reionization epoch, what happened? There was emergence of stars and galaxies, and as a result of emergence of stars and galaxies, what happened? Dark age vanished. Light was able to propagate, light was able to spread, and that's why dark age vanished. Fine. So this Uncover program is getting clues about the end of this dark age of the universe. About Uncover program. So what is Uncover? It is ultra deep NIR. NIR means near infrared. Near infrared cam and near infrared spec observations before the epoch of reionization. That is what is Uncover program. Uncover program is related to JWST. That information is important, not its full form. Full form is not important. Key goals: identifying first light galaxies, discover galaxies that form during the dark ages. Second objective: studying low luminosity galaxies, investigate galaxies responsible for reionization. So why this reionization happened? They say that this reionization happened because of the some galaxies, and those galaxies were called as low luminosity galaxies, right? So that will also be studied under Uncover program. Reionization is the process that causes electrically neutral atoms in the universe to get charged again, right? We discussed that there was a cloud of neutral hydrogen atoms. Those neutral hydrogen atoms again got some charge, and that process is called as reionization process. Fine. So that is what is the key goal of Uncover. Clear this point? Next is Square Kilometer Array Observatory, SKAO project. Square Kilometer Array Observatory. So why news? India will become full member, this term is important, full member of the International Mega Science Project, the SKAO, which will function as the world's largest radio telescope. Right. So about SKAO, so see, what is radio telescope? It will be collecting radiations in radio waves band of electromagnetic spectrum, right? And there will be array of telescopes, right? In Maharashtra also there is one telescope. Can you name that telescope? In Maharashtra there is one telescope called as Giant Microwave Radio Telescope, GMRT. One more is there, 30-meter telescope. Yes, TMT. Which one? TMT? It's microwave. JMRT is Giant Microwave Radio Telescope. So it is also an array of 30 telescopes, each 45 meters in diameter, right? So telescopes, these telescopes are like those cable TV operator umbrellas. You must have seen those dishes, large dishes earlier. You must have seen, right? So 30 such telescopes are there, and each has a diameter of 45 meters. under GMRT. Okay. Coming back to SKAO, India has become full member of SKAO. So SKAO is an intergovernmental international radio telescope project being built in Australia, and in Australia we have low frequency telescopes. That means under radio band we have high frequency ranges and low frequency ranges. So in Australia there will be telescopes that will be able to collect low frequency ranges, and in South Africa we'll have telescopes that will be able to collect high frequency ranges, but of radio waves only. Fine. It is located in radio quiet regions, which are regions usually located in the remote areas where ground based radio transmissions are limited or prohibited. Right. That means in those areas we will not have these towers and all. Right. Will not have these telecom service provider towers. Right. Those areas we will not get any kind of mobile network. Next, the combined infrastructure, the square kilometer array observatory and headquarters are located in the UK, United Kingdom. So the headquarter of SKAO is at UK, right? So this is one important telescope, and another is GMRT. GMRT is important one, and one more we will discuss, and that is called as Pratyush. Right, we'll be discussing about that. Fine. So this square kilometer array observatory. Next. So next point for SKAO. SKAO is being built in the southern hemisphere. So both South Africa as well as Australia, they are there in southern hemisphere, where the view of the Milky Way galaxy is the best and radio interference at its least. Why we are preferring southern hemisphere? Because from southern hemisphere view of Milky Way galaxy is better and radio interferences are least. Objective: transform our understanding of the universe, tackling some of the most fundamental scientific questions of our time. Right, so we have already discussed this point. Why we are observing these X-rays, radio waves, etc., infrared radiations, etc. Why do we observe these kind of bands of electromagnetic spectrum? Why do you see these chairs? Why do you see this board? Because it is visible. Why it is visible? Because it is emitting light towards you, and that light is being used by our brain in order to see the object as it is. Right, that means the light that is coming towards you is a source of information about this object. So similarly, X-rays, let's say produced by some pulsars, they will act as a source of information about those pulsars. Right, there may be some radio waves emitted by certain objects, celestial objects obviously. Those radio waves will act as a source of information, and that's why we are trying to collect these radio waves using SKAO, infrared radiations using GEMS web, then X-rays using XPOSAT, etc., so that our understanding of the universe becomes better, because we have number of mysteries related to this universe. Those mysteries we want to solve. Fine. Next. So next point, India has already been contributing to the project for the past several years as an associate member since 2012, but now we have become full member, right? So statement may be there, if at all question is asked, statement may be there that India has become an associate member of SKAO in 2024. Correct or incorrect? Incorrect. Because associate member we are since 2012. Now we have become full member. So full member status offers greater scientific opportunities, requires countries to sign and ratify an international treaty and also make a financial commitment. Fine. So that is what is SKAO's full membership obligations. Next now. So that is about SKAO. So this is how SKAO looks. Fine. Next now. Next point. Next is INSAT 3DS weather forecasting satellite. So this weather forecasting satellite was launched by ISRO for Ministry of Earth Science. Ministry of Earth Science funded INSAT 3DS weather forecasting satellite was launched. About this satellite, mission type, it's a follow-on mission of the third generation meteorological satellite. Third generation meteorological satellites means we had earlier some satellites were launched by ISRO. They acted as first and second generation. Now we are coming up with modern or satellites with high capacities, better capacities. Those are called as third generation meteorological satellites. Fine. For example, GSLV is called as fourth generation launch vehicle. Why? Because we had earlier three generations in the form of SLV3, ASLV, PSLV and then GSLV, right? And that's why GSLV is called as fourth generation launch vehicle. Next, objectives. What will be the objectives of weather forecasting satellite? Objective is to monitor Earth's surface, then conduct ocean observations. Next, provide vertical profile of meteorological parameters, offer data collection and dissemination capabilities, and one more is there, and it is provide satellite aided search and rescue services. Though this satellite is weather forecasting satellite, it can also be used for some other applications, and one of such application is to aid search and rescue services. Fine. Next, launch vehicle was GSLV F-14 and it has placed this INSAT 3DS initially in GTO and then in GEO. Right? What is GTO? Geosynchronous transfer orbit. What it is? I think information is there on the next slide. What is GTO? We have discussed this. These are transfer orbits. These are not the final orbits. It is highly elliptical orbit to transfer satellite from one orbit to its final orbit, right? And using these kind of transfer orbits, we will be able to launch satellites using such launch vehicles where payload capacity is less. Fine. Otherwise, if you want to launch a satellite directly in geostationary orbit, you will need a heavy capacity launch vehicle, right? That need can be nullified with the help of use of these transfer orbits. Right? So GTO is a transfer orbit. GEO, on the other hand, is an orbit. So satellites in GEO circle Earth above the equator, appearing stationary over a fixed position due to their synchronized orbit with Earth's rotation. This point we have already discussed. Fine. Next. Next is Kulashekar Pattinam spaceport. So it's there in Tamil Nadu. It's there in Tamil Nadu, and it's a second spaceport. This will be ISRO's second spaceport after Satish Dhawan Space Center in Sriharikota, which was established in 1971. And the focus of this Kulashekara Pattinam spaceport will be to launch SSLVs. Right? So this we have already discussed. Can you tell me some features of SSLV? Some features of SSLV. Sorry? Right. So what is the range of payload capacity of SSLV? To carry, it can carry 500 kg payload up to 500 kilometers of low Earth orbit. Who will manufacture SSLV? Don't say ISRO. NSIL. Right.
Dogleg maneuver. So now this is such strategically located, we don't have to go from our real car. Dogleg maneuver is enables us for that.
Dog leg maneuver.
The dog
Okay. Okay. Fine. Any other? Any other feature? How many stages? Sorry? No, that is for RLV only. One more important. So how many stages? 3 stages. Which fuel? Solid fuel. And one more terminal stage called as VTM, velocity trimming module. Right? Because solid fuel we cannot control. So in order to control this solid fuel, we have a terminal stage called as velocity trimming module, where liquid propellants are used. Okay, so that is also an important point for SSLV. Next. So not very important, this Kulashekara spaceport. Next is Statio Shiv Shakti. Again, not very important point. So it is a location, it is a site where Chandrayaan 3's lander has landed. Okay. So, but who gives this designation is important. So its name has been approved by the International Astronomical Union. International Astronomical Union. So Gazetteer of Planetary Nomenclature. So this IAU records planetary names approved. So Gazetteer of Planetary Nomenclature is a kind of database where planetary names approved by IAU are recorded. Right. Second, planetary nomenclature is used to uniquely identify a feature on the surface of planet or satellite so that the feature can be easily located, described and discussed. Right. So not very important point. So just remember that Statio Shiv Shakti is a site where Chandrayaan 3's lander has landed, and this name has been approved by International Astronomical Union. That's it. Next. So IAU, it was founded in 1919, headquartered at Paris. Its mission is promote and safeguard the science of astronomy in all its aspects, serve as the international authority for assigning designations to celestial bodies and their surface features. So this is important mission of IAU. India is a member and there are 92 members including India. So these are some points related to IAU. Next, Methane Sat. What is Methane Sat? Methane Sat satellite was recently launched by SpaceX Falcon 9 rocket from California. What are the key points? Aim is to identify and quantify global methane emissions, pinpointing sources and trends over time to aid in reducing emissions. Right? Methane is one of the potent greenhouse gas. Its global warming potential is more or less than CO2. It's more, but it's there only for a short span of time. Right? There is one important pledge. Can you tell me that pledge? Global Methane Pledge. When it came into being? Which COP? Right, at COP26 Glasgow. India is a member of Global Methane Pledge or not? Why no? किसके पार्ट थे? Obviously, we are UNFCCC member, so obviously we will be there at COP. We are not a part of global methane pledge. Why? Because what is the pledge? 30% reduction in methane emission by 2030. So if we want to reduce methane emission, what is the prime source of methane emission? Carbon? Agriculture and allied activities. Paddy cultivation, for example, paddy cultivation and cattle rearing leads to emission of methane. So if we want to reduce methane emission, we'll have to reduce area under paddy cultivation, and we'll have to reduce this cattle rearing. But this is not possible in India because around 50% of our population is agriculture dependent, and we have huge amount of area under rice or paddy cultivation. So we cannot reduce it. It will compromise our food security as well. And that's why we are not a part of global methane pledge. Came into being in COP26. Okay? One more point is there related to COP26. Have you heard about Clydebank Declaration? It's not related to our topic. Clydebank Declaration. Clydebank Declaration is a declaration that also came into being at COP26, and it is a declaration for green corridors for shipping. Green shipping corridors. Green shipping corridors would be better. Green shipping corridors means those maritime routes where renewable energy based shipping is carried out. That declaration is called as Clydebank Declaration. India is not a part of Clydebank Declaration as well. Why? Because again, if you want to move towards renewable energy in shipping, you will need lots of course correction. You will need lots of finances which are not available in India, right? Because the obligations of developed countries are not being fulfilled. They are supposed to provide $100 billion to every year to developing countries, which they are not providing. And as a result of that, it would be difficult for us to transition towards renewable sources of energy, especially for these kind of, let's say, declarations, shipping. Because shipping right now is not our focus. Our focus is right now production of renewable energy using solar energy, especially for rooftops or for housing related requirements. You must have heard about Pradhan Mantri Suryodaya Yojana, right? Recently launched. Nahin, it's there for all India. So means they have changed its objective a little. Initially, the objective was up to 3 megawatts of solar power generation. Installation would be free. Those households who use less than 300 units, their requirement would be of 3 megawatts of solar energy installation. For them, it will be free. But later on, they have changed this a little. Up to 60% will be free, 40% will be paid by the household. उनको पता चला कि बहुत ज़्यादा cost लग जाएगी इसका. Why we are focusing on this? Because of our NDCs, nationally determined contributions. What is the NDC? 50% of energy should come from non-fossil sources by 2030. Okay, coming back to this. So this methane sat is launched by SpaceX Falcon 9, and it will be identifying and quantifying global methane sources and will analyze sources and trends of methane emission, right? So next point, it is developed by Environmental Defense Fund, developed methane sat in collaboration with Harvard University, Smithsonian Astrophysical Observatory, and New Zealand Space Agency, right? So not very important information. Next, about methane, you must be aware that it is a potent greenhouse gas. 30% of global warming is due to methane. Then it is 80 times more potent than CO2. and it is relatively short. It has relatively short lifespan of 7 to 12 years in atmosphere, while CO2 can persist for 100 years. Next, Chandrayaan 3. So Chandrayaan 3 was successfully launched from Satish Dhawan Space Center in Sriharikota. Then launch vehicle was GSLV Mark 3, right? GSLV Mark 3. And what are the key payloads? 3 key payloads are there. Generally we consider only 2, but third one is also there. What are the 2 payloads? Lander and rover. But another one is there. It is called as propulsion module, right? What propulsion module did? Can you please tell me what was the function of propulsion module? Function of propulsion module was to carry Chandrayaan 3 from the point of ejection into the orbit of moon. For example, suppose this is Earth and suppose this is moon. No. GSLV Mark 3 carried Chandrayaan up to a point only. That point is called as point of ejection. From here, entry of Chandrayaan 3 into the orbits of moon was based on propulsion module. They use slingshot only. They use this kind of mechanism only, wherein they lowered the orbit and finally it entered into the orbit of moon. It must be working on inertia. You see, we will be sending commands from ground station. Will send commands so that its engines will be switched on, so that it will be able to lower its orbit as it is supposed. Gradual descent. See, when we launch it from Earth, we use a gradual ascent, and when we want to allow it to enter into moon's orbit, it was gradual descent. Okay. So that is what is the module: lander module, propulsion module, and rover. What are the key objectives? 3 key objectives. First is soft landing, second roving on the lunar surface, and third to carry out in situ experiments. Fine. So these are the 3 objectives. Next, key findings. Now this is important. What Chandrayaan 3 has found till now: laser induced breakdown spectroscope confirmed presence of sulfur near the landing site, near the South Pole. Other detected elements are aluminium, calcium, iron, chromium, etc. Then Langmuir probe LP is there. Langmuir probe detected. So what is LP? It is also a payload of Chandrayaan 3's lander. Fine. So Langmuir probe detected thin plasma on the moon's surface, indicating that radio waves can easily pass through. So it has detected presence of plasma. Other key points, so these are not very important. So Chandrayaan 3 accomplished soft landing on moon's south pole, becoming the first mission to achieve this near lunar south pole landing. India became the 4th country to land softly on the lunar surface, followed by Japan, which has become the 5th country, and they have achieved this using a mission called as Smart Lander for Investigation of Moon, SLIM mission. Can you tell me another name of SLIM? SLIM is also called as not Japanese name, because of its one key feature. It is also called as moon sniper. It is also called as moon sniper. Why? Because it landed in a predetermined 100 square meter area. It was able to land in a predetermined 100 meter square area, and that's why it is also called as moon sniper. ठीक है. Next, so that is about Chandrayaan 3. Next is Gaganyaan. So basic information is there for Gaganyaan. What is Gaganyaan? It's a first manned mission planned by ISRO, right? And in this, 3 astronauts will be placed in low Earth orbit using a launch vehicle called as GSLV Mark III, which has been renamed as LVM-3, right? So 3 astronauts will be placed under Gaganyaan in low Earth orbit. So objective: demonstration of human space flight capacity by India. Mission details: crew of 3 members will be launched into an orbit of around 400 kilometers, and it's a 3-day mission. Launch vehicle is LVM Mark III. Stages of LVM you are aware of: solid, liquid and cryogenic. Governance: so there is a special agency, special council for this called as Gaganyaan National Advisory Council, which has been created for the Gaganyaan mission. ISRO has indigenously developed environmental control and life support system ECLSS for this mission, right? And this system ECLSS is important so that we will be able to provide Earth-like environment to these astronauts. Fine. So only the US, Russia and China have managed to send manned mission to outer space. Okay? If India is able to launch Gaganyaan successfully, India will become 4th one. Next, fast radio bursts. Scientists are exploring new aspects of fast radio bursts. What are they? What are FRBs? They are mysterious radio signals from distant galaxies. The Laser Interferometer Space Antenna LISA mission will aid in studying FRBs and other mysterious radio signals. Can you please tell me which agency will launch LISA? बोल दो अभी, सारे बोल दो. NASA European Space Agency. It is an upcoming mission. Its prime objective, LISA's prime objective is to detect gravitational waves. Waves. What are gravitational waves? Gravitational waves are ripples on space-time fabric. We all exist in space and time. If there are disturbances on this space and time, those disturbances lead to creation of gravitational waves. Okay? Next. So what are FRBs? They are powerful brief bursts of radio frequency emissions from deep space and last only milliseconds. They release massive energy which is comparable to hundreds of millions of suns. Potential origin: magnetars are the potential origin of these FRBs. A type of neutron star formed from the remnants of exploding stars, proposed as probable origin for FRBs. Magnetars we have discussed already. We have referred to, not discussed. Next, about LISA. So LISA is a planned space probe to detect and accurately measure gravitational waves from astronomical sources. On 25th of January 2024, the LISA mission was formally adopted by ESA. ESA is responsible for spacecraft launch vehicle operations and overall mission design of LISA. Key elements of LISA's instruments are provided by a collection of European national agencies and NASA. Not very important point. It is expected to launch in 2035. And LISA, we have discussed this point. Suppose this is Sun, then LISA will be forming a kind of equilateral triangle around Sun. Fine. So this point we have already discussed. Next is Pratyush radio telescope. So it is being planned by India. It has not been established, but it is under planning, and it will be placed on the far side of moon. High resolution telescopes will be placed on far side of the moon. India has proposed launch of Pratyush. So what is the full form of Pratyush? It's probing reionization of the universe using signal from hydrogen. Right? We have just now referred to reionization, epoch of reionization that led to formation of, let's say, clearance of the universe so that light was able to propagate or spread. That happened because of reionization. So that reionization will be studied using Pratyush. So Pratyush is being built by the Raman Research Institute, RRI, and the ISRO. It will study when the first stars formed in our universe and the nature of the first stars. Initially, ISRO will place Pratyush into orbits around Earth. Right? Initially, it will be around Earth, and then it will be moved towards the far side of moon. So moonward movement will be carried out later. Advantages. It will have advantages compared to ground-based experiments such as operating in free space. So in the far side of moon will have free space. That means it will not be disturbed by, let's say, various kind of radiations, and also lesser ionosphere impact. Ionosphere's impact will also be not there. Lesser ionosphere impact. So this point is not very very correct point. Why? See, ionosphere, where do we have ionosphere? It's a layer of Earth's atmosphere, right? So it's a layer of Earth's atmosphere. So ionosphere acts as a kind of disturbance for the radiations coming from various, let's say, telescopes or satellites, because signals coming from, let's say, International Space Station will have to pass through ionosphere, right? And then only they will reach Earth. So when they pass through ionosphere, those signals get distorted, and that's why we'll have to look for such a place where the ionosphere impact is lesser. But this kind of point is not true for the Pratyush. Why? Because even if Pratyush is placed on the far side of moon, that data coming from Pratyush will have to pass through ionosphere. You cannot bypass ionosphere if you want to use that data on Earth. Fine. So this is not very correct point related to Pratyush. Fine. Next now. Clear Pratyush. So it is a proposed telescope by India to be placed on the far side of moon. Next, Kodaikanal Solar Observatory. So I will skip this point. It has just completed 125 years, and that's why it's in news. Kodaikanal, you must be aware where it is. It's very famous for its scenic beauty. It's there in Tamil Nadu, right? Ooty is more renowned, but more scenic beauty, they say, is there at Kodaikanal. Now, other space missions in news. First is Ingenuity. So, have we discussed Ingenuity? Yes, we have. There is one Mars Explorer mission by NASA called as Perseverance. Perseverance rover is there. Perseverance rover has two very important payloads. One is Ingenuity. What it is? It is helicopter. It's an aircraft, and this helicopter has demonstrated flight in the Martian atmosphere. Martian atmosphere has very low density, and that's why flying in Martian atmosphere is very difficult. But that has been demonstrated by Ingenuity. Can you tell me the second payload, second important payload of Perseverance? MOXIE. MOXIE. What is MOXIE? MOXIE is Mars oxygen resource resource strike कर देना. Mars oxygen in situ resource utilization experiment. Mars oxygen resource in situ resource utilization experiment. Mars oxygen in situ resource utilization experiment. So what MOXIE has done? MOXIE has demonstrated conversion of atmospheric CO2 into oxygen. On the Martian surface, MOXIE has converted atmospheric CO2 into oxygen. Right? And why oxygen is used? Oxygen can be used for two purposes. First is breathing, and second as an oxidizer. It can be used as an oxidizer in the propellant. Okay? So that is what is in ingenuity. Next is Proba 3. This is important. Proba 3 is important. It is European Space Agency's mission, and it will be launched by ISRO. ISRO will launch Proba 3 of European Space Agency. This will be the world's first precision formation flying mission, with two satellites flying in a fixed configuration to demonstrate formation flying technologies and rendezvous experiments. The mission will create a 144-meter long, this point is important. What this mission is all about? This mission is going to create 144-meter long solar coronagraph to study the sun's faint corona, mimicking an artificial eclipse for a continuous view of the corona. Now, we have discussed the layers of sun. The outermost layer of sun is called as corona, right? This corona is not visible to us. We can only see corona during solar eclipse. But can we wait? If we want to study corona, can we wait for solar eclipse? No. And that's why scientists have developed an instrument called as coronagraph that allows them to study corona of sun even if there is no solar eclipse. Fine. And this flying this solar coronagraph, solar coronagraph will be placed by ISRO under Proba 3 mission of European Space Agency. Right? It is a mission of European Space Agency, and what it will do, it will act as a kind of solar coronagraph. What will happen because of solar coronagraph? We'll be able to study sun's corona. Fine. So mimicking artificial eclipse for the continuous view of the corona. So that is what is Proba 3. Next. Next is Intuitive Machines mission. So SpaceX launched a private US moon mission 52 years after the last Apollo lunar mission. So the IM-1 flight carries the lander Nova C Odysseus and 6 NASA payloads to gather data about the lunar environment, aiming for a soft landing near the moon's south pole at a crater named as Malapert A crater. What is important? What is important? Name is important. Intuitive Machines mission. It is a private lunar mission from the US based organization. That's it. These days, number of lunar missions are in news. First is Chandrayaan 3 of ISRO. Next, Artemis of NASA. Next, Luna of Russia. Slim of Japan. IM, Intuitive Machine of US based private organization. That's it. Okay. The mission targets the bay of stickiness adjacent to the Grythaesan domes near Oceanus Procellarum on the moon. These names are not important, right? It is targeting a certain area on the lunar surface, right? It is near Oceanus Procellarum, not important. Okay, so just remember the name, Intuitive Machines. Next now, so that is about other space missions. Next, satellite based toll collection system. So the government of India is planning to pilot test a global navigation satellite system, GNSS based electronic toll collection ETC system on national highways. So how this GNSS based toll collection system works, it has certain important components. So using satellite based navigation imaging to track the position of the vehicle and collect toll based on the distance traveled. So what, simply put, what it will be. So if there is a highway, let us consider that there is one highway, right, and there are these roads which are not highways. So suppose there is a vehicle which is entering from this road on the highway. So on this, at this particular place, there will be cameras. There will be cameras. Those cameras will capture the number plate, right? So registration number will be captured, and then this vehicle will have a global navigation satellite system based unit. So based on that, the vehicle will be tracked, and let's say at this particular point it is exiting from this highway. It is exiting from this highway. So here again we will have the cameras. At the exit points also we will have cameras. So this vehicle, see, highway is bigger than the let's say distance covered by this vehicle. So this vehicle has covered, let's say, 100 kilometers of distance. So it will be charged for that 100 kilometers only. So what will happen as a result of this? As a result of this, we don't need any toll collection system. You must have seen there are toll collection booths, separate toll collection booths. Those we don't need. Based on the movement of vehicle on the highway, which is captured by these cameras, and the length of path will be calculated based on the global navigation satellite system based unit in that vehicle. Based on that, that vehicle will be charged. Okay, so now you will understand better. So working, it uses satellite based imaging to track the position of the vehicle and collect toll based on the distance traveled. What are the main components? First is onboard unit. This onboard unit is nothing but global navigation satellite system based unit. So a GNSS enabled device installed in the vehicle to determine the vehicle's route and calculate the toll. Fine. So it will be based on this particular onboard unit. Automatic number plate reader cameras installed on highways to recognize vehicles number plate and deduct toll money. So ANPR uses optical character recognition on images to read vehicle registration plates and create vehicle location data. Not important. So this and this point is important. Onboard unit, which is GNSS enabled, and automatic number plate reader cameras that will read the, that will let's say recognize the vehicle's number plate and deduct toll money. Fine. Next, what are the benefits? Decreases the need for roadside toll collection infrastructure, reduces congestion, enhances toll collection effectiveness. But there are challenges as well. Small signal interference or inaccurate readings. So if cloudiness is there, then it won't be able to capture signals properly, and that's why we won't be able to know exact distance traveled by that vehicle. Right? Then privacy concerns are also there, because cameras are clicking pictures of those vehicles, and that's why there may be some privacy related concerns. The need to equip older vehicles with GNSS technology, not important. Implementation in other countries. Right now 2 countries are there where we have these kind of toll collection systems. It is Germany and Singapore. Next. Next is defense related developments. So we have already discussed this. First is high altitude pseudo satellites. So it has been developed by CSIR NIL, National Aerospace Laboratories. CSIR NILs has completed the first test of solar powered high altitude pseudo satellite vehicle known as HAPS. Remember this name, this is important. HAPS. It is an unmanned aerial vehicle UAV. HAPS can reach an altitude of 18 to 20 kilometers, nearly double that of commercial aeroplanes. The cost of operating HAPS is substantially less than the satellite. They can remain in air for years, having advantage similar to those of satellites. Applications, for which applications we can use them? For border surveillance and monitoring, and for disaster relief as well. So whichever be the application of drones, for those applications we can use HAPS. Next, S-400 Triumph. So why it is in news? Indian Air Force has reportedly deployed S-400 missiles along the borders with China and Pakistan. So you know S-400, it is an anti-missile system procured by India from Russia, and its capabilities are that it can protect against a wide range of aerial threats including drones, missiles, rockets and fighter jets. This point is important. It can protect against drones, missiles, rockets and fighter jets. It has some important components. First is command and control center, automatic tracking and targeting systems, launchers and support vehicles. Then it also has radar systems which will detect aerial targets up to a range of 400 kilometers, right? So the range is up to 400 kilometers, and simultaneously it can detect almost 80 aerial targets, right? So these are the components of S-400 Triumph. Can you name indigenous anti-missile system that we have in India? Indigenous anti-missile system. It's ballistic missile defense, BMD, ballistic missile defense, obviously developed by DRD. Next, other air defense systems are also there. First, no, they manufacture this LCA Tejas and all. जो aerocrafts है, fighter aircrafts है, वो manufacture करते हैं, HA. ठीक है? So next is other air defense systems. First, USA has first THAAD, which has already been asked by UPSC in 2018's prelims examination. Right? Simple question tha. THAAD, sometimes seen in the news, is what? Right? So that is one. Second is Patriot Advanced Capability, that is PAC-3, again of USA. And third is National Advanced Surface to Air Missile System, NASAMS system, NASAMS. We in India were trying to procure this NASAMS, but we have not procured it as of now. Okay? So these three are important anti-missile systems of the USA. And then after USA we have Israel.
It cannot intercept fighter jets.
It cannot intercept fighter jet. That means it's primarily meant for missiles. Right? S-400 can intercept all drones, missiles, rockets, fighter jets. That capability is not there in THAAD. Next, Israel. Israel has two important air defense systems. First, you know, Iron Dome, right? And second is David's Sling. Names are important. So David's Sling used to intercept Hamas rockets. Components are not necessary. Okay? Just remember the names. Iron Dome is very famous. Another one is David's Sling. Next, MQ-9B. NQ9B is US made drone, and we are trying to procure it, MQ9B Reaper, designed to fly over the horizon via satellite over 30 hours. It can safely integrate with civil airspace. Why this point is important? Because there may be some civilian airspace that is used for surveillance. So this MQ9B can integrate in that system in a better way, so that we can use the civil airspace along with MQ9B Reaper. Equipped with advanced maritime intelligence, surveillance and reconnaissance, and that's why this MQ9B Reapers non-combat version is used in Indian Navy because of its 360-degree maritime surveillance. We use it in Indian Navy. Okay? It enables real-time search and patrol above and below the ocean's surface. Okay? And Indian Navy plans to equip these MQ9B with sonobuoys. That means small devices used for underwater acoustic surveillance. Sound-based surveillance, underwater sound-based surveillance will be carried out by MQ9B, as they will be equipped with a device called as sonobuoys. Which sound they will be trying to detect? Sound of submarines. Because as submarines operate, they may create some sound, and that sound will be detected by the MQ9B, which also uses sonobuoys. I hope it is clear to you.
We have already opted this.
We already have MQ9B, but it is non-combat. It is non-combat. Now we are planning to take from US, we are trying to procure combat versions of MQ9. Okay? Next now, health and diseases, health and medicine. So first is Yaoundé Declaration. So it's a declaration of 11 African countries that have committed to zero malaria deaths. Yaoundé is a capital of Cameroon. So participating countries are these. These countries carry the highest burden of global malaria infection and deaths. The declaration includes a commitment by African heads of state to allocate 15% of their annual budget for health. 15%, right? So what is important? Yaoundé Declaration is related to which of the following? It is related to zero malaria death in 11 African countries. Next, so we have already discussed this, tartrazine and rhodoamine B. These are the chemicals that are used for that are used as coloring agents. Fine. So Tamil Nadu, Goa, Karnataka becomes the first state in South India to ban use of certain coloring agents in cotton candy and gobi Manchurian that found to be harmful. So rhodoamine B, it's an organic chloride salt used as coloring agent in textile, paper, leather and paint industries. Prohibition, it is banned by FSSAI. It has been banned by FSSAI in India. Right. Next, other harmful banned food color chemicals. Next is tartrazine and sunset yellow. They can cause allergic or pseudo-allergic reactions. And next is carmoisine, which can cause skin rashes and respiratory allergies. Fine. So these are also the banned chemicals in India. But remember, rhodoamine B, it was in news because of this issue related to cotton candy. Next is Uvicol S oral cholera vaccine. So recently WHO pre-qualified a new oral vaccine for cholera called as Uvicol S. What is pre-qualification? That means it will be assessed for its safety, for its efficacy for the treatment for the cholera, right? It will be assessed for its safety efficacy related to cholera. Next, about it is a simplified formulation of oral cholera vaccine Uvicol Plus, manufacturer South Korean company. It can pave the way for a potential solution for the critical shortage of OCV worldwide, right? So these oral cholera vaccines are not available in a large amount. There is a shortage, and we'll be able to overcome this shortage using this Uvicol S, manufactured by South Korean company. Vaccine, currently there are 3 WHO pre-qualified oral cholera vaccine, and Uvicol Plus is one of them. Cholera, so what is cholera? Cholera is a waterborne disease which is caused by a bacteria. And how one can get exposed to this? One can get exposed to this because of contaminated food and water. Next. So that is what is Uvicol S. Then Men5CV vaccine. So it is, so why it is in news? Nigeria has introduced the world's first vaccine against all strains of meningitis, right? Men5CV vaccine is a vaccine against meningitis. So about the vaccine, approved by WHO, it safeguards against all 5 strains of meningococcus bacteria in one shot, surpassing earlier vaccine. So for other strains, for different strains of meningitis related bacteria, we were supposed to take different kinds of vaccines, but with the use of Men5CV, single vaccine will do for all types of meningitis. Next. So what is meningitis? It is an inflammation of fluid and 3 membranes called as meninges surrounding the brain and spinal cord. Causal organism, it can be caused by various organisms like bacteria, viruses, fungi and parasites. But mostly the transmission is based on, or most of the diseases are related to virus and bacteria. So transmission, some viral and bacterial meningitis are contagious and can be transmitted through coughing, sneezing and close contact. Meningitis belt, so there is a meningitis belt and it's there in sub-Saharan Africa, where the rate of incidence related to meningitis is very high. Next is lumpy. So more than 100 cows have died due to lumpy skin disease in Meghalaya. So what is lumpy? It is an infectious viral disease primarily affecting cattle. Symptoms are not important. It affects, or what is the result? Results in reduced milk yield in affected cows. Distribution, originally it was found in Africa, but now even in Asia, Middle East Asia, Asia and European, Eastern Europe, we have spread of this particular disease. Transmission happens through blood feeding insects like flies, mosquitoes and some ticks as well. Prevention, controlled through attenuated virus vaccine. See, for viral diseases, vaccines are the most important let's say treatment, right? We do not have antiviral medicines for viral diseases. Why? Because viruses are notorious to keep changing their strains, right? They keep on mutating, and that's why antiviral medicines are not very effective against viral diseases, and that's why what we have to use, we have to use vaccines. So that is what is lumpy. So then ethylene oxide is in news because of the ban on Indian masalas from various countries like Hong Kong, Singapore and now even Nepal. So what is ethylene oxide? It is colorless, highly flammable and reactive gas. So it's a gas known for its bactericidal properties. That means it will be able to act against bacteria, and that's why for these masalas for fumigation, we use this gas. Fumigation, you must be aware. So for during malaria, वो malaria जब होता है तो वो gas spread करते, you must have seen, that is called as fumigation. So to treat masalas so that they are not affected by bacteria, we carry out fumigation of a gas, and that gas is ethylene oxide. Okay? So ethylene oxide is classified as group 1 carcinogenic by the International Agency for Research on Cancer. It is a pesticide used by spice industry to reduce microbial contamination. Okay? Chronic exposure, even at low levels, can increase the risk of cancers like leukemia, stomach cancer, breast cancer, along with respiratory and gastrointestinal issues. Ban on ethylene oxide. European Union has already banned use of ethylene oxide. But we use it in our masalas, not in our masalas, but to protect our masalas. That means the ingredient will not have ethylene oxide. But to protect that ingredient from bacterial actions, we will fumigate it. For fumigation, we use this gas. Sometimes the percentage of the ethylene oxide in the masala would be more than the permissible amount, and that's why it has been banned. Okay? In ingredients, we do not use it. See, permissible, within permissible limits, you can use it to preserve masalas. It's a kind of preservative, not exactly, but it acts against bacteria, it acts against microbes, so that the shelf life of masalas increase. But FSSAI won't be able to monitor the limits in which that ethylene oxide is present in our masalas. Next is Nipah virus. Its outbreak has been seen in the state of Kerala. So Nipah is a zoonotic virus, and its host is fruit bats of this Pteropodidae family. Name is not important. Host is fruit bats. It can also be transmitted through contaminated food or directly between people. That means human to human transmission is possible. In zoonotic diseases, pathogens may be bacterial, viral, parasitic, or other unconventional agents. So it is a zoonotic disease caused by a virus. Other prominent zoonotic diseases are rabies, brucellosis, Japanese encephalitis, and plague, and even Zika. Fine. Not Zika, COVID-19, you can consider COVID-19. Next, the spread of zoonotic diseases has increased due to use of antibiotics in animals and reduction in forest cover. Not very significant point. So Nipah is a zoonotic disease caused by virus, and its outbreak has been seen in state of Kerala. Next, HeLa cells. So we referred to this. So there was a lady named Henrietta Laux. Her family settled a lawsuit against a biotechnology company for the use of her cells for profit, and that's why those cells are called as HeLa cells. So she died in 1951 due to a cervical cancer. Without her knowledge or consent, doctors took a sample of her tumor and sent it to lab, where it was discovered that her cells could grow indefinitely in culture. Culture means when we provide them favorable environment, those cells were able to grow, and that those cells are called as HeLa cells because means it's named after her name only. It's named after her only. So her cells, known as HeLa cells, become the first immortalized human cell line and one of the most widely used in biomedical research. And it is used for various kind of researches related to polio vaccine, gene mapping, cancer treatment, AIDS research, cloning, stem cell studies, COVID-19 vaccines, etc. Fine. So what are HeLa cells? These are the cells that have been recovered from a lady who passed away in 1951 itself, and her cells are used for various scientific research related to vaccines development, stem cells, etc. Okay. Next is optical tweezers. So researchers at Raman Research Institute use optical tweezers to study structural details of leponite, a synthetic dye, a synthetic clay, leponite. So optical tweezers are scientific instruments that use a highly focused laser beams. So as name suggests, optical, that means they'll be using light radiations, and what they do using those light radiations, they'll be able to manipulate the microscopic and submicroscopic objects like atoms, nanoparticles, droplets like tweezers. Fine. Next now. So about leponite, leponite is a synthetic clay that has ability to swell and when placed in water, and it has various properties, and because of these properties it can be used for these applications, right? So properties are, they have negatively charged surface, they have aqueous gelatin properties. Aqueous gelatin properties means their viscosity increases as temperature falls. Their viscosity increases as temperature falls. And as a result of that, we can use them for these different applications. Okay? So we can go through these applications. Next, energy. So in energy, we'll discuss first point, and that is related to battery energy storage systems. So this has been developed by the Solar Energy Corporation of India Limited at Chhattisgarh. Fine. So what is Solar Energy Corporation's battery energy storage system? Firstly, we will discuss that. So about battery energy storage system. So what they use, see, they use various kinds of electrochemical reactions in order to store energy, right? Because this energy generated by generated using solar energy is also in the form of electricity, and electricity is a kind of energy. So that electricity will be stored in the form of chemical energy in these kind of storages, and for that we use various electrochemical reactions. So BESS is classified as electrochemical storage system utilizing different electrochemical reactions to store electricity. It can function independently or as part of power system infrastructure at various levels, including generation, transmission and distribution. That means we can use these BESS storage systems at various levels. We can use it at the level of generation, we can use it at the level of transmission or at the level of distribution. So types of BESS, this is not very important. Standard non-flow batteries and flow batteries, right? So standard non-flow batteries are the batteries that we use in our devices, and flow batteries are the batteries where we use certain kind of chemicals stored in different containers, and we allow those chemicals to flow. In our standard batteries, do chemicals, that means electrolytes, flow? They do not flow, and that's why they are called as non-flow batteries. But there is another type of batteries where the electrolyte or chemicals are able to flow, and that's why those batteries are called as flow batteries. Okay? Then these components are not very important components, because in most of the batteries we'll have, in all different types of batteries, be it non-flow or flow, will have electrolyte, will have electrodes as well. But in the non-flow batteries, as we have already referred to, there will be no flow of electrolyte. charges will flow but not electrolyte. In case of flow batteries, they utilize a tank of electrolytes and a membrane to control the flow of electrons with pump to manage the flow of electrolytes. So electrolyte will also flow in case of flow batteries, and they are used in there are two types of these flow batteries called as redox flow batteries and hybrid batteries, not very important. Lithium ion batteries you can go through, it's self explanatory, you can go through. Okay? And there are advantages and disadvantages also. And then last point is related to indigenous fast breeder reactor. So we know that fast breeder reactors are a stage 2 of Indian nuclear program, and core loading of fast breeder reactors was done in the month of March 2024 by the Prime Minister of India. What is core loading? Core loading means we allowed fuel to enter inside the core of nuclear reactor, right? And what happens because of this event of core loading of fast breeder reactor marks beginning of the second stage of Indian nuclear program. So officially second stage of Indian nuclear program has started. Okay? So in fast breeder reactors, which fuel do we use? Which fuel do we use? See, we have discussed this point that Indian nuclear program is a closed fuel chain program. That means the output of first will act as input for second, but not alone. Output of first stage is plutonium-239. So plutonium-239 will be used as an input for second stage. But along with plutonium-239, we will also use natural uranium. Okay, natural uranium will also be used. So you can go through this point. We have already discussed Indian nuclear program in detail, so you can revise that thing. So FBR technology and fuel. So initially uses uranium plutonium mixed oxide fuel. Plans to use thorium as a blanket to produce more fissile uranium-233, key for the program's third stage. So in FBR, that means in the second stage itself, we start use of thorium. Thorium, but that is phase 2 of stage 2 of Indian nuclear program. In the phase 1, what we use? We use uranium plutonium oxides. Okay? So that is about our discussion of this science and technology current affairs. Updated current affairs, not complete. If you have any doubt, you may ask. Clear है? थोड़ा सा information based part हमने quickly cover किया है, especially health वाला part. But it's a one-liner part. वहाँ पे ज़्यादा explain करने की चीज़ें नहीं है. It's one line. Any doubt? No? Shall we stop? Thank you and all the best.